Hi everybody, welcome to How to Solve by Computer series. This session is about how to write algorithm for partitioning the array. Let us understand the problem. Given a randomly ordered array, partition the array into two subsets such that the elements less than or equal to x are in one subset and elements greater than x are in another subset. Now, look at this array. So this has 10 elements. Now you need to divide this array into two subsets based on your x value. Remember, this x value may be the element of the array or may not be the element of the array. Now my requirement is you need to divide this into two subsets such that one subset will be having less than or equal to 17 and another subset will have greater than 17. Now one way to approach this problem is you can sort the array, arrange the elements in ascending order, then it is easy for me to divide them into two subsets. So when I arrange the elements in ascending order, I really know that this partition, I can easily find out this partition and find out these elements are less than or equal to 17 and these subset are greater than 17. But sorting is a very expensive operation because we need to do a lot of exchanges when sorting is done. So, since sorting is a costly operation, we need to find out an algorithm that will minimize the number of exchanges. So, look at this output. Again, this satisfies our condition, but the elements are not arranged in ascending order. Okay. So we see that this set is also less than or equal to 17 and this set is also greater than 17, but it is not in sorted order. Okay. So we need to find out, remove this sorting operation, convert this input into this output. Now, how do we do that? Take the input array and x is equal to 17. Now you take your output array and observe what is happening here. Now as you see the first element and you see the last element, they are getting exchanged. Okay, so they are getting exchanged. What is the next observation? The second element here and the last before element getting exchanged. So 6 has come here, 26 has gone there. But what about the next subsequent sequence? It is not the third and last one will be exchanged. Okay. Now what is happening is these things are skipped and only 25 and 12 are getting exchanged. Okay. So now the idea is you have to scan your array from both the ends, left and right. When you scan from left, okay, when you start scanning from the left, if you observe that particular value is greater than your x, stop. Okay. Then now you start scanning from the right. Stop when we see an element less than or equal to x. And if left and right scanning do not overlap, okay, what you need to do is exchange the values. That is the logic we write. Otherwise, you will stop. If your left and right scanning are exchanging, then you have to stop, which indicates the partitioning is complete. Okay. So now let us observe this. So how do we do that? Take the array, mention the positions of the array. Now x is equal to 17. I make use of two variables, I to indicate the position from the left and j to indicate the position from the right. It is referring to the position, not the element. Remember that. Now I observe the value here in this position, that is I is equal to 0 initially, j is equal to 9 and the value present in this position is 28. 28 is greater than 17. So when you do left scanning, if the value is greater than 17, you need to stop. And so stop here and do the right scanning. So when you observe here, this value is less than 17. So you need to stop in the right scanning if the value is less than 17. So J will stop here. Now what is the next process? You have to interchange these two. So these two values will get interchanged. So it will become 10 and this will become 28. Okay. Next step is you have to increment your I. Now it has become less than 17. So automatically I will be incremented and it comes here. And again it finds that it is greater than 17. So it will stop. Now scanning proceeds from the right. J comes to this previous position. Now it finds that it is this value 6 is less than 17. So it stops. Interchange. So you get 6 here, 26 here. After that I will get incremented. Now again it sees that it is greater than 17, so it will stop here. Okay. Now coming to J, now it will go to the next position. Now it is greater than 17. So greater than 17 means it has to proceed with the previous one. So it is greater than 17, it will move here. It will stop only when that value is less than 17. Okay. So it will just proceed with the previous one and it will stop here because it is less than 17. Okay, so less than 17 means what will you do? Now you need to exchange. So that is how this 12 and 25 will get interchanged. Now what happens? The scanning will proceed with the left. So I will come to this position. It is less than 17. So it will move on to the next position, less than 17. It will move on to the next position. But here it is greater than 17. So it will stop here. Now proceeding the right scan. Now this is greater than 17. So it will go to the previous position. But this value is less than 17. So it will stop. Now you can find that I and J has crossed. So how do I say I and J is crossed means this I position becomes greater than J. Okay, so that is how we find out the crossing between the I and J. If I and J crossed, then we need to stop, which indicates that our partition is over. So you can look here, all these values are less than 17 and all these values are greater than 17. So that's it. We have finished doing our partitioning. So now we'll convert these observations into a logic. So what is your input? So the input is array of n elements and as well as your x. And what do you do in the process? As I told you, we'll be using two index variables I and j. I will be pointing to the first element. So I is equal to 0. J will be pointing to the last element. We have n elements. So my last position will be n minus 1. And do the left scanning. So how do I do? If a of I is, see here, a of I means that element. Okay. I is the position. So if it is greater than or equal to x, we will stop. Otherwise, what do? I will increment I by 1. And similarly, when I do right scanning, whenever this a of j is less than x, I will stop. Otherwise, I will decrement j by 1. Then what do? I will repeat this as long as your I is less than j. So exchange a of I and a of j. Then increment a by 1, decrement j by 1. Again, you do the process. Okay, so you'll be comparing the left scan, right scan, and do incrementation and decrementation accordingly. So this will be proceeded as long as I is less than j. So when I is greater than j, it will stop, where j will give me the partition point. So output will be the same array, but with the interchanged values. So it will indicate P is the partitioning point. So in the array, you can now find the elements which are less than or equal to x in the left part and greater than x in the right part. Now we can convert this logic into the algorithm. So what do? I will read an array of n elements. So my array name is A, starting with the index 0 to n minus 1 and x. Initialize I is equal to 0 and j is equal to n minus 1. And then you have to do the left scanning. So as long as your a of I is less than or equal to x, you increment I by 1. Otherwise, you go with the right scanning. A of j is greater than x, then you decrement j by 1. Otherwise, what do? You will check whether I is less than j, then you try to interchange. So interchange could be done using a temporary variable, as you know. So a of I to I and a of j to a of I and t to a of j. So these three steps will make the interchange between the a of I and a of j. Then you will be incrementing I by 1, decrementing j by 1, and again you do the left scanning. So we'll be writing a of I is less than or equal to x, you increment. Otherwise, you just go with the right scan and check whether a of j is greater than x, decrement j by 1, and you need to repeat the same thing as long as I is less than j. If I is greater than j, it will come to this step where you are setting your partitioning position, that is j. So then you print the array of array elements which will generate these two subsets. Now we'll verify this algorithm. So what do we do is write down the array. N is the number of elements, x is the element on which your partitioning will happen, and I and j, as you know, belonging to the left scanning and the right scanning. And what do you check? A of I is less than or equal to x and a of j is greater than x. And one more checking do you do with I is less than j. So write down all these things. And in your step 2, what you have written is array elements. So I have taken some randomly some elements and my x is equal to 50. Okay. Now third step is initializing I and j. Fourth step, I will be checking with a of I is less than or equal to x. What is a of I? I is 0. So a of 0 is 18. 18 is less than x. I am checking. Okay. So 18 is not less than x. Okay. So what do? I proceed with the right scale. Remember the process what we have done. So next, what do? I'll go to sixth step and I will check whether a of j is greater than x. What is a of j? J is 4. My element is 16. So whether 16 is greater than 15? Yes. So if it is yes, what do? I'll decrement my j. Okay. So I'll go and decrement my j. So j will become 3. Now again, what do? Again, I will be checking whether this element is greater than x. So 2 is greater than 50. No. So I will stop. Okay. Next step, what do? I will check whether I is less than j. So what is my I value? 0. J value is 3. So it is less. So what do? I need to interchange. So what interchange I need to do? I will be interchanging a of 0 and a of 3. So a of 0 is 18, a of 3 is 2. So these 2 will get interchanged. So 2 will come here and 18 will go here. Then after interchange, what I am doing? I am incrementing I and I am decrementing j. Okay. So my I will become 1 and j will become 2. Okay. Next, what do? Again, I will start comparing a of I is less than or equal to x. So now a of I, that is it is 12, is less than or equal to x. Yes. Yes means what do? I will increment my I. Okay. So this is proceeding. So I is equal to, I have written the same process. So I am comparing a 7 with 15. So it is yes. So what do? I will increment my I. So I will become 3. Okay. Next, 18 will be compared with 15. So it is no. So I will stop there. Okay. Next, proceed with the right. So at present j is 3. So it will just check whether 7 is greater than. Just look at this j value in the previous slide. So I haven't copied that. Okay, j value is 2 here. So at 2 I have 7. So 7 is greater than 15. I am checking no. Okay. So what do? I will check whether I is less than j. But it is telling me 3 is not less than 2. So you should not interchange. Okay. So it should not interchange means now we have ended our partition. So our P is equal to 2, which indicates that that is the partitioning position, which means till 2 you have one subset, after that another subset. So it is getting divided into two subsets. 2, 12, 17 is forming one subset and 18 and 16 are forming the other subset. So this is what you need to print. I hope you have enjoyed this. Thank you for watching. Subscribe to my channel to see my next video. Thank you.